All right, everybody, welcome to another edition of Accelerated Minutes. I'm Mike Muldowney from Accelerated Machine Design. I'm here with my colleague Evan Cruz, also from Accelerated Machine Design. Evan's a proud grad of Rose-Hulman Institute of Technology. And Ev, you had a chance to put some of those Rose-Hulman tactics to use with your engineering skills over the past project here. We invest a lot in computer-aided software for design and simulation. But sometimes you reach limitations in that, and you had an opportunity to put your skills to use and go above and beyond where the software hit its limitations on your last project, right?
Yeah.
It was a mission critical marine application where there was no prototype, there's no second chance. We had to get it right on the first chance, and having engineers like Evan on the team make that possible. Evan, you want to tell us a little bit about what you did and why you had to get into the paper, pencil, and whiteboard?
Yeah, sure. So it's a hatch cover basically, and it's a folding mechanism. So it's basically just a complex linkage system, 4-bar linkage system. It's a little more complex than a basic 4-bar linkage though. As the hatch folds up, it's hydraulically actuated. So one of the links is changing in length as it moves. So we were trying to study the motion of this hatch cover and see how it's going to behave as it opens and closes, and we tried to use simulation software to see what it would do, and the software just wasn't behaving. It was showing really weird behavior. No matter what I tried, it didn't make sense. So after days of scratching my head trying to understand why it was doing what it was doing, sat down at the whiteboard, kind of drew out some free body diagrams and tried to extract some more knowledge from the situation. And what I found was the software wasn't doing what it should be doing. So at that point, I thought it was worth the time to go in and make a math model of the system. And I've got all these papers here, so I started sketching stuff down, drew a bunch of free body diagrams, drew a bunch of vector loop equations to find out how are these panels and the bars, the linkage is going to move as the cylinder retracts or extends. So took quite a while, but went through and did all the vector equations for position, velocity, acceleration, and then I was able to use that information to back out forces and just total behavior of the system. So now we have a really good understanding and a model of how the system's going to work, and we can use it to update all the kinematics like link lengths, positions, speeds, and we know exactly what's going to happen as this thing moves, whereas before we really didn't know. So feels good to get some pencil to paper and draw some free body diagrams.
That's awesome. Well, we're grateful for the work you do. Our customers are grateful for the work you and the team do. And it's people like Evan that make it possible to handle some of the most, as said before, mission critical or incredibly precise tolerances that we need to handle on these projects. And it's good to have this accelerated minute with you. I hope you all have a nice day. More to come. Thanks.
Thanks.